Okay, this is an explanation for quantum numbers, what they are, how to get them, and what they mean. So, first, quantum numbers, there are 4 of them. They are code numbers that tell us what kind of atom it is. We've talked about how the atom is like a hotel. Is it like a Motel 6 with a single story and only one kind of room? Or is it more like a lavish hotel with like 8, 9 floors and all different kinds of suites, from honeymoon to presidential to single, double, kings and queens? So these are the 4 numbers. The first one is called the principal quantum number. Its symbol is a lowercase n. It tells us how many energy levels it has. In other words, how many stories is the hotel? So what can n equal? N can only equal 1, 2, 3, all the way up to infinity. N cannot equal 0. It cannot equal a negative number. It cannot equal a fraction. And it does go all the way up to infinity, but right now we only have 7 principal energy levels. So how to get it? It's the horizontal row on the periodic table. This row is often called the period. Here is periodic table. See these numbers? These are the n's, the values of n's. So as you can see, sodium has an n of equal to 3. These guys down here, notice how it runs from 57 to 71. They technically fit in this little spot right here. So they're a 6. They're an n equals 6. These guys, 89 to 103, they fit in this little spot. They're technically an n equals 7. Now, the second quantum number is called the angular momentum, sometimes called the azimuthal. It is a cursive L. What does it tell us? It tells us the shapes of the orbitals that hold the electron. In other words, what types of rooms does this hotel atom offer? Is it just a single? Does it have some doubles? Does it have kings? Does it have suites? So what's L equal to? N minus 1 all the way back to 0. How do you get it? Well, you got to have n first, and then you subtract 1 and you get all the way back to 0. Example. We already talked about how sodium is an n equals 3. So sodium's L is 0, 1, and 2. See, it's n minus 1 all the way back to 0. So 0, 1, and 2. So sodium is a 3-story hotel, and it's got 3 types of rooms, which is what I'm going to talk about in just a second. It's got 3 types of rooms. The magnetic quantum number, symbol is m lowercase l or sub l, tells us how many of each type of room there are. In other words, how many singles do you have? How many doubles? How many kings do we have? How do you get it? What's it equal to? It's equal to plus or minus whatever L was. So you got to have L in order to get the m sub L. So didn't we say here that n is equal to 3, L is equal to 210? So m sub L is equal to plus and minus 3, plus and minus 2, plus and minus 1, and 0. I'm sorry, plus or minus 2, back that up, plus or minus 1 and 0. So that's 5 rooms, 5 types of each room. Now, the spin quantum number, that's the last one. This is the easiest, but it's also the hardest because it just seems so simple. The spin quantum number tells us what direction an electron is spinning. There are only 2 directions to spin, clockwise or counterclockwise. Hence the 2 numbers. Plus 1/2 is clockwise, minus 1/2 is counterclockwise. See, electrons don't like to be together, so when they're put in one of these hotel rooms together, they start spinning, and they spin in opposite directions to get away from each other. All right, so this is a short definitions list video of quantum numbers. In the next video, I'm going to talk more about some specifics with examples.